In this video, we will review a collection of topics that all together are referred to as trigonometry. The main objectives of this review is to understand the place of trigonometry in the landscape of lower division math courses, and identify the main subject or subjects of interest and tasks that we learned in trigonometry. And to answer the first question, let's take a look at this map that I presented to you in one of the earlier videos. And here we can see that a sequence of courses, pre-calculus, calculus 1, calculus 2, form what we can call a pipeline from the beginning of mathematics into what we can refer to lower division math courses. And trigonometry sits right before the precalculus on one of the two branches, the other one being the algebra. So while trigonometry has started as a study of triangles, it really outgrew that initial subject of interest very fast and spread out into many other things. So what exactly one is expected to learn in trigonometry? A student who successfully completed a trigonometry course must be proficient in the following four tasks: solving triangles, graphing trigonometric functions, solving trigonometric equations, and working with trigonometric identities. When it comes to solving triangles, we didn't learn everything overnight. There are three stages of learning how to solve triangles. First, we learn how to use the Pythagorean theorem and well-known ratios between the sides to solve nice triangles. Next, we learn how to use the definitions of the six trigonometric ratios to solve right triangles. And finally, we'll learn how to use the laws of sine and cosine to solve any triangles. When it comes to graphing, we must give trigonometry a lot of credit for its contribution. Why so? Because after completing a full algebra sequence, you only learned 8 functions altogether. Here is the list. But when you take a trigonometry course, you learn 6 trigonometric and 6 of their inverse functions. Altogether, 12 functions, which is a major chunk of all the functions that you must know before entering a calculus sequence. As a result, you are expected to know the graphs and basic properties of trigonometric functions and their inverses. Here is the graph and a list of basic properties of sine function. Here is the graph and a list of basic properties of arcsine function. Here is the graph and a list of basic properties of cosine function. Here is the graph and a list of basic properties of arccosine function. Here is the graph and a list of basic properties of tangent function. Here is the graph and a list of basic properties of arctangent function. Here is the graph and a list of basic properties of secant function. Here is the graph and a list of basic properties of arcsecant function. Here is the graph and a list of basic properties of cosecant function. Here is the graph and a list of basic properties of arccosecant function. Here is the graph and a list of basic properties of cotangent function. And finally, here is the graph and a list of basic properties of arccotangent function. When it comes to solving trigonometric equations, we also didn't learn everything overnight. First, we learn how to solve simple trigonometric equations. Here is the summary of the methods for solving each one. There is also a fancy way of writing all of them, including the first two, in a single line formula. Similarly to how we have a quadratic formula for solving quadratic equations, you can think of each of these methods as a formula that you may either memorize or have it available when solving basic trigonometric equations. When it comes to solving other trigonometric equations, we usually utilize either a substitution technique or solve it by graphing. Here's an example of solving the same equation using both methods. Here's another equation solved using both methods. Pause and review the solutions if necessary, but make sure you know at least one method. The last skill that you must have after completing a trigonometry course is to be able to work with trigonometric identities. Let's briefly discuss what are they and what is there to do with them. An identity is an equation that is always true. Trigonometric identity is an equation that involves a trigonometric function. Here's an example of a few basic trigonometric identities. Trigonometry is not the only subject that has identities. There are, for example, algebraic identities as well. Here is a few that you should recognize. So what do we do with identities? Identities provide a playground to exercise one's analytical skills. In a standard trigonometry course, you are expected to spend some quality time trying to prove a range of trigonometric identities. But once you're out, you're only expected to remember the basic ones. I will provide you with the following two charts that I developed in my regular trigonometry class. The first chart summarizes all the basic identities, including the ratio, reciprocal, and Pythagorean. It shows how the six trigonometric ratios relate to one another. The significance of this diagram is that it visualizes the fact that from any given trigonometric ratio, we can find the remaining five. The second chart summarizes all other identities that one needs to know after taking a trigonometry course. The identities are grouped according to their type, and each group has a name. Now, I wish I could end the review here, but we have one more task to discuss. And next, we will review a procedure for simplifying trigonometric expressions of certain type that frequently appear in calculus. Here are a few problems of such type. Notice how the pattern demands that an inverse function must be inside of another trigonometric function. Let's consider a generic problem of this type. There are only 36 possible combinations of trigonometric and inverse trigonometric function, so it is just a matter of time before you try all of them. So let's get started. First, we introduce theta by labeling everything inside parentheses as theta. The original expression is now very simple in terms of theta. But what do we know about theta? From its definition, we know the domain of theta and can produce the following statement. Next, we recall the definitions of both involved trigonometric functions. Now, we can draw a reference triangle with theta in standard position and label all the sides appropriately. We then use the Pythagorean theorem to find the missing side. And finally, we can plug in the needed sides into the expression in question. So let's simplify the following expression. First, let's introduce theta by labeling everything inside parentheses as theta. The original expression is now very simple in terms of theta. What do we know about theta? From its definition, we know the domain of theta, and we can produce the following statement. Next, let's recall the definitions of both trigonometric functions, cosecant and cotangent. Now we can draw a reference triangle with theta in standard position and label the adjacent side as 7 and the opposite side as 5. Now we can use the Pythagorean theorem to find the missing side. And finally, we can plug in the opposite and hypotenuse into the formula for the original expression. So we simplified it. We discussed what one is expected to know after completing a trigonometry course and before entering a calculus sequence. The format of this review didn't allow me to get into too many details, so if you would like me to, please let me know in the comments.